All right, welcome back, my seventh grade advanced class. Let's begin. We got the review and refresh here, so let's start with that. It says find the area of a triangle. We're going to start by remembering that the area of a triangle can be found by knowing the formula of a triangle, right? So first of all, let's remember that a rectangle, the formula for a rectangle is base times height. And since a rectangle contains two triangles, we can go ahead and take that formula and cut it in half. So the formula for a triangle is 1/2 base times height. All right, so let's use that. Find the area of these triangles. We've got 15 inches and 8 inches as our base and our height. So when I take my formula, 1/2, base is 8, times the height, 15. 1/2 of 8 is 4, and that leaves 4 times 15. 4 times 15 is 60, so that means this triangle is 60 inches squared. And we say squared because, remember, area is two-dimensional. I'm going to let you do number 2, and now I'm going to work on number 3. Simplify this expression. We're going to use our PEMDAS here. First thing we have to do is look into the parentheses to see if there's anything we can do. I cannot combine unlike terms. 3p and -6 are unlike terms because this -6 doesn't have a p afterwards. For them to be like terms, my variable has to be the same on both of these to the same power. So now I'm going to go on to multiplication, and that's where this parentheses comes in handy. 2 times 3p is 6p. And 2 times -6, that's -12. Plus 4p. Now I can combine like terms. Remember, I have 6p and 4p, both of them end in p, and they are to the same power. So 6 plus 4 is 10. That leaves me with 10p minus 12 is my final answer. I'm going to let you go ahead and work number 4 out yourself. Number 5, tell whether -3 is a solution to this. Well, this is an inequality problem. I know that because there's not an equal sign here. That means one does not equal the other. So when I look at this, I have to remember I can combine like terms, even if they're on opposite sides, by using inverse operation. The -4 and the -12 are both numbers, they're integers, so I can combine them. I do this by combining it with the opposite integer. I'm going to add 4 to this side to get rid of it at this side, leaving me nothing with 2n. But whatever I add to one side, I have to add to the other side. Think of this like a scale. If I put 4 more pounds over here, I have to put 4 more pounds over here to keep everything equal. -12 plus 4 will give me -8. Now I see that I have to get 2 away from n. They're multiplying right now. I need to do the opposite to get rid of that 2, so I will divide it away. I'll turn it into a fraction because I know this is 2 divided by 2, and that leaves me with n by itself. But again, whatever I divide from one side, I have to divide from the other side. -8 divided by 2 is -4. And so my answer says tell whether -3 is a solution. Oh, I'm sorry, I do have to erase this really quick. I'd put an equal sign here, and I shouldn't have done that. It should have been a greater than sign. So they're saying n is greater than -4. Now, is n bigger than -4 is the question. If I look at the number line, and I say that this is 0, and I say this is -1, -2, -3, and then -4. Where would you say -3 is? Is it bigger than -4 or less than -4? Well, as you can see, if n is bigger than -4, all the numbers this way are bigger than -4, right? and -3 is one of them. So is it a solution? Yes, it is a possible solution, one of many for this problem. -2, -1, all these numbers that are bigger than -4 would work. All right, let's move on. Comparing numbers in different forms, determine which number is greater. To do this, I have to put them in the same form. I'm going to put them as decimals because that's the easiest for me to read. 4 2/5. I have to turn into a decimal. There's two ways to do this. I can either go ahead and go around the world and say 5 times 4 is 20, and 20 plus 2 would be 22 over 5. And then I could go and use my calculator and say that 22 divided by 5 is equal to 4.4. That's one way I could do this. And since it's asking which one is greater, I would say that 4.4 is greater than 4.3. The other way I could do this is to say, okay, I know that 4 has to be my number in front, my whole number. Now I'm just going to take 2 over 5 and divide it. So 2 divided by 5 is going to give me 0.4. So now I can just add in the 0.4. And you can see either way, I'm going to get the same answer, whether I go around the world and make the numerator bigger, or I remember to bring the 4 in front as a whole number and just divide the numerator by the denominator in my fraction. All right, you've got number 7 to do. I know you might be thinking, Mr. Mendez, this has a percent in it. Just remember that when you have a percent, to turn it into a decimal, you simply move the decimal place over 2 spots. This would be 8 or 0.82. You're going to treat this fraction the same way you did this one over here. All right, this says converting between percents and decimals. Write the percent as a decimal or the decimal as a percent. Use the model to represent it. So if I'm going to turn this percent into a decimal, I remember to move the decimal place over 2 spots. This is going to be equal to 0.26. Now, if I'm going to use that in here, I remember this is 26% out of 100%. So I'm just going to come and put the highlighter here. I'm going to put it to green, and I'm going to shade in 26 of these blocks. There's 10 by 10, so there's 100 of these blocks, which means I'll simply shade in 20 and then 6 more. And that's what it would look like. Okay, now the next one shows a decimal here. And they're saying if it's a decimal, turn it to a percent. We simply do the opposite of what we did here. We're going to move the decimal place over 2 spots, and this will be equal to 63%. Once again, I'm going to use the highlighter and shade in 63%. So I'd shade in 6 rows. And then I would do 3 more. And that leaves me 63 out of 100. All right, the others are for you to do. Concept skills, it says, write the percent as a decimal or the decimal as a percent. Use the model to represent. Once again, we're doing the same thing that we did a little while ago, except they're doing some decimals here, okay? And that's fine. You should not be scared. I'll show you how to do, let's see, number 12 and number 14, and that should make it easy for you to do the rest. In fact, let me do one of the harder ones here. I'll do number, let's see, how about I do number 14, and then I'll do number 16. That should cover all the bases for this. Okay, so if I was going to do number 14, I would say this is 39.2 percent, I move my decimal over 2 spots, which means this is going to equal 0.39 to repeating. I'm simply going to go ahead, shade in 39 of these. So that's 1 row, 2 rows, 3 rows, and 9 of the next row. And since this is 2 repeating, just a little bit more to indicate that I'm showing that little bit extra for the 2 repeating. All right. Now, if I was going to do number 16, the reason I picked this one is because it's a number bigger than 100. Okay. And you're going to have a couple of these to do here. Once again, I would go ahead and move my decimals to make this into a decimal. I would bring it back, or I would go forward 2 spaces, 1, 2, bring back 2 spaces, excuse me. This will equal 1.23. Now, you might be thinking, well, how do I put 1 here when all of this would be 1? Well, what I would do is make another box here. Make this your 1, and I would go ahead and shade that entire thing in, indicating I knew that that was 1. And then I'd come over here and shade in 23 more. Oops, got a little bit overzealous there. There we go. And then 3 more. All right? All right, and the rest of these are for you to do. Next, concept skills and problem solving. Your friend writes 4.8% as a decimal. Is your friend correct? Well, he wrote this over here, and it looks like he moved the decimal space 2 to the right. But when it's a percent, you should be moving that decimal space 2 in the other direction. So no, he's not right. Uh-oh, sorry about that. Just type this in. No, he is incorrect. It should be, let's see, I'm going to go with, since it should be 2 that way, 0.048, right? Because if we were moving this, it would be going in this direction. And I'm sorry, for some reason it's creating a highlighter straight line instead of my pin here. Let's try that. You'll be moving it over twice here, putting a decimal here and putting a 0 there. But remember that 8 is still repeating, so I'm still going to have to put a line over my 8. All right, let's move on. Writing fractions as decimals and percents. So this time we are taking a fraction and turning it into decimals, right? Write the fraction as a decimal and a percent. So let's do this one first, 29 over 100. This is really, whenever you see a fraction, it's really a division problem. So this is 29 divided by 100. As you already know, you're going to have to put a decimal here and put a 0 there. This indicates that you're adding on to 29, and your number is going to have to be after the decimal. Well, we would pick 2 because 100 goes into 290 2 times, and that's going to leave me 90. Once again, you'll add a 0, and 100 goes into 900 9 times. So our answer is 0.29. That's how we would write it as a decimal. Now, as a percent, I would move that decimal over 2 spots, so it also equals 29%. All right? And let's see, I go ahead and do number 23. I'm going to do this one with a calculator, as I know many of you will probably do. If I take 7 and divide it by 8, I'm going to get .875. And to turn it into a percent, I'd simply move that decimal place over 2 spots, and it's 87.5%. All right, let's go on to number 25 through 32. Write the fraction as a decimal and a percent. Well, we just did this, didn't we? So I'm going to leave this for you to do. Remember, every one of these are just division problems. Number 33, order the numbers from least to greatest. Now, there's going to make us take every one of these numbers, find out what it is as a decimal, and then put them in order in the form that they're in up here. So let's do an example, number 33. This one here says 66.1%. We know we have to move that decimal over 2 places, so this would be 0.661. All right, that's what that is as a decimal. Now we're going to do the next one. It says 0.66. It's already written as a decimal, so I will simply put 0.66. The next one says 2/3. Well, remember, every fraction is really a division problem. This is 2 divided by 3. And when I put my decimal here and add my 0, I know 3 goes into 20 6 times. Unfortunately, this leaves us another 2. So we're going to keep on multiplying 3 to 6 in order to go ahead and get the next number. This means this is equal to 0.6 repeating. So this next one is really 0.6 repeating, which is 6666666. All right, the last one is in decimal form already, and that is 0.667. All right, now we've got all the numbers we need to see which one is the smallest. Well, it's easy to see the smallest one is going to be this one here, because this ends in 6, and then there's going to be a 0 here. This is 0.661. This one is 6666, which is bigger than 0, and it's a 67. So 0.66 will be our first one from least to greatest. Next, I'm going to say 0.661 because 661 is less than 0.6666 and it is less than 667. So the next one is 66.1%. Remember, we have to write it in the form that it's shown in the problem, not the answer that we got when we turn it to a decimal. All right, next, we're going to go with 0.6 repeating because we know that 67 is bigger than 66. So now we're going to have 2/3. And the last one, of course, is 0.667. It is bigger than all the other numbers here. All right, 34 is yours to do. I'm going off to 35. Tell which letter shows the graph of the number. Okay, so I'm going to do number 1 here. Remember, every fraction is a division problem. This is really 7 divided by 9. I bring the decimal down. 9 goes into 7 times for 63. And unfortunately, that leaves us with 7 again. So that's going to mean that this is going to be repeated. I'm going to constantly get a 7 up here. So this would be 7, 7, which equals 0.7 repeating. So 0.7 repeating has to be right over here between 0.77 and 0.78. So I would say this equals A. All right, I'm going to let you do the other 4 on that, and we're going to move on. Just for number 36 to 37, remember, if it's in decimal form, you already know where to go. If it's a fraction, take the top number divided by the bottom number, and if it's a percent, move that decimal over twice before you start looking for it, okay? All right, let's move on. I think I'm going to go ahead and do number 40. So the table shows the portion of gold medals that were won by the U.S. In the summer in 5 Summer Olympic Games. In what year did the U.S. win the least portion? This, I think you guys can do this. Once again, you're putting all these in decimal form. If it's a fraction, divide the top number by the bottom number. If it's a percent, move the decimal place over twice, then compare all the numbers and see which one is the least and which one's the greatest. Number 41, real life, modeling real life. You and your friend and your cousin have a basketball competition where each person attempt the same number of shots. You make 70% of your shots. Your friend makes 7 out of 9 of her shots. Your cousin makes 0.72 repeating of his shots. How many times more shots are made by the first place finisher than the third place finisher? All right. Well, the first one is 70%. That's what you made. And remember, we have to take the decimal, move it over 2 spaces. So this is going to equal 0.7. Next, it says your friend makes 7 out of 9 of her shots. So 7 out of 9 is 7 divided by 9. And I think we already did this one, right? 7 out of 9 makes us go ahead and use 7, and then that makes 63, giving us a remainder of 7. So you know we're going to keep on using 7, which means that this one for her, this was you, right? So we're going to write this over here. You made 0.7. She, whoever her is, she made 0.7 repeating. And then your cousin which is obviously a boy, he made 0.72 repeating. Now, it's saying how many more times, how many more shots are made by the first place finisher than the third? Well, let's see who came in first, second, and third. In first place is always got to be the biggest number. Remember, this is 0.7 repeating. This is 7777. That will be more than 0.70. And that will be more than 0.72. So the first place went to the girl. So first place, 0.7 repeating. And that was equal to 7 over 9. That will be important later. The last place person looks like you because 0.72 repeating is bigger than 0.7. So now we have the first place person. And we have the third place person. So it says how many times more shots are made by the first place finisher than the third place finisher. To do this, we're going to need our calculator. So I'm thinking we're going to have to take the least amount and divide it by, no, we're going to have to take the biggest amount and divide it by the least amount. So to do this, we're going to have to take, there's no way to type in 0.7 repeating, so we'll put 7 divided by 9. That gives us 0.7 repeating. Next, we're going to divide this by 0.7. That gives us 1.1 repeating. So that is how many times more. So our answer is going to be 1.1 repeating. All right, and I'm just going to highlight this to indicate this is our answer from all our work that we put. All right, let's see. I'm going to let you have number 42 and 43. I think I'm going to go ahead and take number 44 here. 44% of the students in the class, over 44% of the students, or 30 students in the class, read a book last night. Wow, I really butchered that sentence. Over 44% of the 30 students in a class read a book last month. What are the possible number of students in the class who read a book last month? All right, so to do this, we have to remember that part Sorry, I forgot that I didn't have my marker on. All right, so let's see. Part equals the percent times the whole. That's our formula. So if I use that, the part here is what I'm looking for. What part of these 30 students? The whole would be the 30 students. That's all the kids in the class. Then we have the percent, which is 44%. Now remember, in order to go ahead, this is being multiplied to 30 here. In order to multiply percent to a number, I have to turn it to a decimal. So I'm going to move my decimal over twice. This becomes part equals 0.44 times 30. And we'll pop this in our calculator. 0.44 times 30 is equal to 13.2. Now, we have to remember it says, what are the possible number of students in the class who read a book last month? And it says over 44. So that means this could be a bigger number. If that's so, it would have been better, I guess, instead of putting this equal sign, we could have used an inequality sign to indicate that this amount has to be bigger, right? So let's see. The part has to be bigger than this amount because it was over 44. Now I have to say, if it's 0.2, there's no such thing as 0.2 a person. That means at the minimum, it has to be 14 kids or more. Students. All right, let's see. I think I'll leave number 35 for you. That's pretty easy, fill in those blanks. Okay, the rest is for you to go ahead and do. I will check all these in class with you. Have a good night and see you in class.